kind of just introduced resistance. It's a very important topic. So the unit is an ohm. And so why is resistance important? Well, it's useful for loads, like we just demonstrated with this. But you have to think about it in a lot of applications. So, for example, when I'm transmitting power across a long distance, even wires that are supposed to be conductors aren't perfect conductors, they have a resistance. And so, as I transmit power through that wire, it actually uses up power in transmission. And so you have to think about resistance in that case. So how can I design a material to transmit electricity? What do I have to think about when I'm designing a wire for production? Well, there's a formula. So resistance equals resistivity, which my rows are terrible. There we go, that's better. So, resistance equals resistivity, which is a value based on the chemical properties of the material, times the length of the material divided by the area. So, let's say I have a 1 meter wire, and let's say it's going from point A to point B, and it's 1,000 miles, or 1,000 meters. That'd probably be easy. And I have a resistivity of 0.5. So what would my resistance be for that wire? You can use your calculator.
Would it be 500?
Yeah. So it's a pretty high resistance, right? You're going to lose a lot across that. So, I mean, realistic resistivity values are very low. So for copper, it's getting really low. Gold, even smaller. So when you're thinking about what you, like, basically for a long distance power transmission, you're going to want the biggest wire possible in order to minimize the resistance, because as you transmit power, you're losing it over that distance.